The periodic table is a huge part of chemistry. You have to learn how to use it. Now, when I first took chemistry, which was actually in college, I didn't take it in high school because it wasn't offered, very small high school. I was absolutely like terrified of the periodic table. I didn't understand it. I didn't understand what it was used for, and I didn't understand how useful it was. So I don't want you to feel that same way. So I have a scenario for you. Imagine, if you would, for just a minute, you um, you need to find out some information about someone. Now, growing up, I went to a little bitty high school, Chautauqua High School. There was 18 in my graduating class. Yes, you heard that right, 18. And it was actually a very large class. Now, with so few students, and I had these same students in my class from kindergarten all the way through 12th grade. Most of them, at least. A few came in later on, few left. You know how it goes. But I knew their first names, their last names, their middle names. I knew their phone numbers. Of course, phone numbers at that point in time were only 4 numbers, not as many as we have today, because you just had to have those last four because everyone lived in the same town. I knew what month their birthday was in. I knew so much about everyone. And so if you needed to get a hold of someone or needed to know anything, it was pretty easy to do. Now, after high school, I went straight to Kansas State University. Talk about a little culture shock here. Little bitty town, great big university. Now, I was lucky. I got into a very small department, so I had lots of personalized attention. But it was a little bit different. I lived that first year at a place called Clovia House, which is a scholarship house for 4-H students mainly. So, a bunch of rural girls is mostly what it was. Very, very economical. So if you go to K-State, check it out. It was a good place for me to be that first year. And there were 60 some girls in class or in the house. I got to know their names, but I couldn't memorize all those other things about them. Number one, I wasn't around everyone enough. Number two, there was just too many. But you can start categorizing, or you can start trying to put them into different groups. And we're going to see that's what happens with the periodic table. Now, today, we store a lot of that information, not necessarily in our brains, but in our wonderful cell phones. It is amazing how much information this little phone can hold. So let's say you're at college, you have a roommate, you get locked out of your room. So what are you going to do? You're going to pick up your phone and you're going to call your roommate and say, hey, lock my keys inside the room. Can you help me out? But what happens if you don't have your phone on you? Would you know how to get a hold of your roommate? Let's say instead of your roommate, you need to get a hold of your mom. Please tell me you have your mom's cell phone number memorized. I'm going to be honest, I don't. I know my dad's. I know their house phone, but not their cell phone. I think I have all of my kids as personal children. I think I have all their cell phones memorized. I think. But this, you don't have to memorize anything. And so that's what we're going to find with the periodic table. There's so much information on it. You don't have to memorize it, but you have to know how to use it. So even if I handed you my phone and I said, hey, here, call so-and-so, you could probably figure it out, even though my phone is slightly different than yours. So you'll see on periodic tables, they may look slightly different, but they all contain the same information and they're all used the same way. So let's get a little bit of the history of the periodic table and start from there. So credit for the modern periodic table is given to a guy by the name of Dmitri Mendeleev. Now I'm not Russian, I probably mispronounced it, but this is the most common pronunciation that I hear. Now this was first published back in 1869. So let's do a little history lesson. What's happening in the US in 1869? Now again, I am not a history buff. I like some history, especially in that time period, but it's not my major. So 1869. Okay, we're a country. We just had the Civil War. We're still in the Reconstruction period, nowhere really close to World War One just yet. So we're just finished Civil War, country is still kind of in shambles, trying to pick up from that. Now, the story goes, and there's actually a link on your other page that gives something called Crash Course Periodic Table or something like that, and they tell a great story about Mendeley. So check that one out. Now, at that point in time, there are 63 known elements. Now, remember I said whenever I was in a class of 18, I knew everything about everyone. But once I moved to K-State and had 60-some kids in the scholarship house, it became more difficult. And that was what was happening. We knew enough elements that it was becoming difficult to be able to keep them all straight. Now, rumor has it that Dmitri was a card player. And so, what he did is on a card, he wrote down all of the information that was known about each of the elements. What the element was, what was its mass, what phase was it in, how would it react with different other substances, what was its melting point, anything that they knew, they would write down on these cards. And what he supposedly did is he started laying them out. And if you look at a periodic table, it almost looks like a solitaire game laid out in front of you. And you know, if you've played solitaire before, that there's certain rules to where you can lay things, and there's some sort of certain order. That's what you see with a periodic table. He organized them according to atomic weights. Now, we do something different today, but he used those atomic masses that were known at that time, and he found out that certain properties repeated themselves. They were periodic. I'm paid periodically. I'm paid the last business day of the month. I know on the last business day of the month, I have money in the bank. The first day of the next month, it's gone. But that last business day, I've got some money. So he found that certain properties, whether it be the phase or how it reacts or what the melting point is, something about it repeated at a regular interval. Now, the really cool thing that he did is he figured out that there were some elements that we hadn't discovered yet. And so he actually left spaces for those. That's why he's given more credit than some of the other people that discovered about the same thing about the same time. There's a guy named Julius Myers from Germany. But Dmitri actually left those spaces. And they discovered elements based on his predictions. That's pretty cool. Today's periodic table is now arranged by atomic number. Okay, pop quiz. What's atomic number? It's the number of protons. Now remember, Dmitri had his by atomic mass, which we know today is protons plus neutrons, but we've found that there's a couple places in the table where they're switched. Where the number of protons versus the number of protons and neutrons are actually off from one another just a little bit in the order of those atomic masses. Now, Dmitri had actually recognized this, and he thought that the masses were calculated incorrectly at that point in time. Because remember, in the 1860s, we don't have a lot of technology. So it was kind of crude instrumentation. Now, today we know it's actually because of the number of protons, but protons weren't invented back in the 1860s. They weren't talked about until 1910. Now, we have also some special names. The first name is a group or a family. These are going to be the vertical columns, and vertical goes up and down. Now, what we find is that they all have similar chemical characteristics if they go in these groups where they go up and down. So, how many of you have siblings? So if you have a sibling, is there some sort of resemblance between the both of you, or all of you, however many there are? Is there, maybe you have similar hair colors or eye colors or face shapes or body types, or everyone is individual, but oftentimes you'll see this resemblance among family members. Maybe you know certain families where you're like, oh yeah, that is definitely so-and-so's kid. Or yeah, they're definitely related to one another. Now, people always say that my kids are very, very similar to one another. You'll see a picture here in the next chapter. So that's why sometimes they're called families. Now, the reason that chemicals, or I'm sorry, not necessarily chemicals, elements do the same thing is because they have the same number of what we call valence electrons, or electrons in their outermost shell. You're going to learn more about those in the next section also, or in the next chapter. And that causes them to have similar chemical reactivities and properties. So groups, families, up and down. Periods are horizontal, they go across. There's 7 periods going down. There are 18 groups going across. Some of them have special names, and we'll get to that here in just a bit. Okay, so here is a periodic table that I just pulled out of your textbook. There is a link to one on the Moodle page that I highly recommend that you print out. You might actually print out a couple of copies of that so that you have it available to you as you're doing your work. Couple things I wanted to point out. Your groups are these things that go up and down, those vertical columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, there's 18 of them. Now, we're going to find that I actually use a slightly different numbering technique sometimes. I like for you to know both, the 1 through 18, and then we have one called the North American system, which I'll show you later on. The periods are the rows. So here's period 1, 2, 3, 4, 5, 6, 7. There's 7 of them. And these things down here at the very bottom, those aren't separate rows. They actually belong in the middle of the periodic table. They go there, and we'll hear more about those in just a little bit. The colors will represent a few things. There's all sorts of things that we're going to learn about this. Atomic number, where everything is. Notice on most periodic tables, the atomic number is listed at the top. So here, they've just pulled out one element to look at more closely. The atomic number, remember, that is the number of protons. That's going to be listed at the top. We have the chemical symbol. Some of them also have the element name. The periodic table that I have posted for you does that. I really like that. You have no reason to misspell the element names. At the very bottom, we have the atomic mass. That's what Mendeley actually had everything arranged by. If you look really close at the periodic table, you'll see 2 different places where the atomic masses don't go in order. Down at the very bottom, it just gives you a few informations about metals, nonmetals, and metalloids. You'll hear more about that in just a bit. So the periodic table can tell us all sorts of really cool things. It's kind of like your phone. Remember, your phone can do all sorts of really cool things. So can the periodic table. One thing it can tell us is the phase of matters, or what's called the standard state. Is it a solid, a liquid, or a gas at room temperature and atmospheric pressure? You will see a slight difference in different periodic tables for this one. Not all of them will show this. The one that I posted for you, again, be sure to print it out. It does have some things in different colors. The ones that I have up on the board will do this, but I know when you print them, it usually prints it in black and white. Generally, if it's a solid, and you'll find out that most elements are solid at room temperature, they're black. Liquid or gases will depend on what periodic table that you look at. The periodic tables that I use most often have blue for liquids and red for gases, but your textbook switches those. Don't ask me why it does that, it just does. There are a lot more gases than there are liquids, just remember that. You can also tell if something's going to be a metal or a non-metal. Now, metals, in your mind, close your eyes for just a minute, think about what is a metal. What does it look like? You'll probably say it's shiny, it's hard, you can work with it, and it conducts. And you'll find out that that's what a metal does. It's a good conductor, it's malleable, and it has a luster or a shine to it. Now, if you go back to the periodic table on that previous slide, you'll see this black line. It steps down. Looks like a little staircase. That's actually the dividing line between your metals and your nonmetals. The metals are to the left. It's the majority of the periodic table. The nonmetals are to the right of that line. They're the opposite of metals. That's why they're called nonmetals. They're insulators, meaning that they are not conductive. Not conductive. Let me write that on here. Not conductive. and that could be heat or that could be electricity, doesn't matter. They don't like to conduct electricity or heat. They're brittle, meaning that if you hit them, they shatter. The opposite of that, a metal, is malleable, meaning that if you hit it, you can work with it, it'll flatten out. Non-metals are brittle, they shatter, and they're usually dull. They can be colorful. We have yellow and purple and brown and all sorts of colors, but they don't have that shine, that luster that most metals will have. Right in between those two areas, we have an area that are sometimes called metalloids. Metalloids, there you go, or semi-metals. These are elements that have properties of both metals and nonmetals. They generally act as a nonmetal, except some of them will be conductive. The most famous one that we'll talk about, silicon and germanium. They are both used in the computer industry for computer chips because they don't heat up, but they will conduct electricity. Makes them really unique. So depending on which side of the line they are, they could be a metal or a nonmetal, plus they're also a metalloid. So let me look at my nice little periodic table I have over here on the wall. Si, silicon, if you go back and look at where that line is, it is to the right of that line. So it is a non-metal, but it's also touching the line. So because it's touching that line between metals and non-metals, it's also considered to be a metalloid. Arsenic is the same way. It's to the right of the line. It's a non-metal, but it is touching the line, so it is a metalloid. The only exception to that is aluminum. Aluminum does touch the line, but it only has metallic properties to it. All right, time for a little question. There is some material found on Earth that would not be found on the periodic table. True or false? That is false. Everything, all matter, is composed of chemicals. Chemicals are composed of compounds. Compounds are composed of elements. All elements are on the periodic table, all 118 of them. So everything that you would find, material, actual matter, is on the periodic table in some way, shape, or form. All right, another question for you. Fluorine is in the halogen family and has properties most related to what element? Your choices: bromine, nitrogen, oxygen, and neon. Well, this one, you need to have the periodic table to be able to look at it. And remember, with the periodic table, we said that if they're in the same group, that they are going to have very, very similar chemical properties. That's because of those valence electrons. So if you look at these, bromine is in the same group. It's a halogen also, so it's going to be most closely related to it. So remember, all of the elements that we see in everyday life, everything's on the periodic table, and all matter is composed of those elements, whether it be on this earth or actually anywhere in the universe as far as we know. It's all on the periodic table. But depending where you're at on the earth, the ratio of those elements will change. So what we've done is we're going to look at 3 different areas of our physical environment. We're going to look at the crust. Now the crust is just the top layer of the earth. We're not looking at the composition of the entire earth because, you know, we have the core and the mantle. We're just looking at the crust for this one. The hydrosphere is everything containing water, so your oceans, rivers, lakes, and groundwater. And then the atmosphere, and the atmosphere is those gases that surround the earth. Underneath that, we have a pie chart for each of those areas looking at the most abundant elements in those areas. It would be a great idea for you to go back and look at those a little more closely. So in our atmosphere, the most abundant gas that we have is actually nitrogen. Nitrogen is 78% by volume of all of the gas. Oxygen is 21%, argon is 0.9, and then every other gas that's in our atmosphere is less than 0.1%. It's kind of crazy when you think of it. So 99% of our atmosphere is nitrogen and oxygen. If we look at the hydrosphere, okay, remember hydrosphere is water. Well, what's water made out of? Water's made out of H2O. You'll see that the largest volume is actually oxygen. Even though there's more hydrogen atoms, when we look at the actual volume, the oxygen takes up more space. So we have oxygen and then hydrogen. And then if you think of the ocean, well, we know it's a salt water, so you'll find that the next two elements are actually chlorine and sodium, which is kind of a cool little scenario right there. So for the hydrosphere, the water, mostly oxygen, we got a good amount of hydrogen, and then sodium and chlorine. Now the crust is a little more spread out. So the crust is the one down here at the very bottom. On the crust, we have just under half is oxygen, and then we have silicon. So silicon and oxygen make silica, and you'll find out that most of the rocks are some sort of silica-based type thing. And then we have aluminum, iron, calcium, and all these other elements. So go through and make sure you know the top probably 2 or 3 elements from each of those different physical environments. So we looked at our physical environment, but what about us as a living thing? So it turns out for a human, 96% of the volume of your body is made up of oxygen, carbon, hydrogen, and nitrogen. Just 4 elements make up 96% of your body. Most of those are oxygen. Again, we are looking, this one looks at average percent by mass. Then we have carbon and then hydrogen. So even though there's more hydrogen atoms, because carbon and oxygen are so much larger, that's where that mass comes from. So most abundant by mass is oxygen, and then carbon, and then hydrogen. And then we have some of those others, nitrogen and calcium for your bones and all sorts of stuff. Now, with the body, we have a lot of what are called trace elements. These are things that we don't have a whole lot of it. It's very low abundance, but they are required for life to exist. Can you imagine if you didn't have calcium in your body? And you have to have calcium for bones. So if you were missing the calcium, you wouldn't have bones, or they'd be it just wouldn't work very good. So we have lots and lots of trace elements. All right, time for a couple little quizzies. Woohoo! The first one says the most abundant element found in the Earth's crust. Now remember, we looked at that just a few slides ago. Is it iron, oxygen, silicon, or aluminum? Your correct answer? Oxygen. Make sure you know the top 2 or 3 for each of those different areas. Now, if we were looking at the core is iron, but the crust, oxygen. One last little polling question for this particular chapter. Oxygen is the most abundant element in the Earth's atmosphere, hydrosphere, and crust individually. Is oxygen the most abundant element in the atmosphere, the hydrosphere, and the crust? True or false? What do you think? Well, correct answer is false. In the hydrosphere and crust, by mass or volume, oxygen is the most abundant, but in the atmosphere, it's nitrogen. So even though we require oxygen to breathe, to be able to live, it's not the most abundant element in the atmosphere. So hopefully that gives you a little more information about some of these different areas that we talked about in this particular chapter. Get ready for that wonderful chapter test.